Okay, we're gonna add on to what we were doing last time. Last time we only had one input and one output. Now we're gonna combine multiple signals, multiple inputs. So as you can see here, there was one input and one output on our inverter. But now we're gonna use an AND gate and an OR gate. So let's start by building a truth table with these. Let's do the OR gate first. What is the rule of an OR gate? The output is high when at least one input is high. So we got to add to our, can't just have one input now. We need two. So here are all the different combinations of inputs that you could have. Output is high when at least one input is high. Where is that here? That's here, here, and here. So one input is high, at least one input is high, output high. At least one input is high, output high. At least one input is high, output high. Now let's do our AND gate truth table. The output is high when all inputs are high. So let's draw that. All inputs are high. When are all inputs high? Here. That is 0. That is 0. Input high, output high. How does that look? Gate look. Here's an AND gate. Show an AND gate. Input, input, output. Let's draw an OR gate. Input, input, output. Previously, we had our inverter, which was one input, one output, like that. Okay, now let's code that up in Verilog. So what define our ports? Input wire A, input wire B, output wire AND gate, output wire OR gate. Now, same thing, we need a continuous assignment, just like for our inverter. Assign equals A. Here's our AND gate. AND is how we write it in Verilog. OR gate. This is how you write OR in Verilog. AND gate. and gate, or gate, or gate, or gate, and gate.